Welcome students back into our videos. Right, feel free as usual and follow the discussion until the end. Right, I welcome you all. Right, without wasting our time in today's business, in the video, we are there just to prove the previous theorem that we started up with. Go back to the video in case you weren't with us. Those who were with us, be able to remember what we've been discussing. We're introducing to the first theorem. That's a property about the circle. That's angle subtended at the center, and that angle subtended at the circumference. There we are referring into the angles which are subtended by a particular arc. From what I mentioned, say for here I've got my figure with me. We have an arc like A, B, right? If you were with us in the previous video, and would say if here is the center O, and here is an arc with the points A and B, the lines of from which are meeting at the center like this. Look, we say that this arc AB is subtending angle at the center, because this arc is opposite to the angle which is at the center. And the same arc can also be opposite to the angle at the circumference. In this way, a line from A again and B can also meet at the circumference like that. So here we are also saying the same story, that the arc AB is opposite to angle at the circumference, as it was earlier from what I explained to say the arc is opposite to angle at the center. So in this case, we are saying that this arc AB is subtending angle at the center, meaning to make, and again, the same arc is subtending an angle at the circumference. So from what we saw, we were just like by measuring using a protractor, we observed that the angle at the center here, which is subtended by this arc, is twice angle that it's subtended at the circumference. Meaning to say, if this happens to be 100 degrees, then angle at the circumference, this point may be T, is equal to what? 50 degrees. Today, we would like to prove this. Is it really true that this one is 2 times angle at the circumference? Right. Yes, by measurements, it's really true. Right. So please be free there and try to observe what will be discussed in this video. Our target is here to prove that property we started up with. Angle subtended at the center related to angle subtended at the circumference, referring to the angles which are subtended by the same arc. Right, so here we'll be discussing on how we can prove a property. Right, if you are asked to prove a particular theorem or a property, usually in geometry, will demand you always to refer to a particular diagram. Right, so like in this case, our target is to prove that angle as subtended at the center is equal to twice angle subtended at the circumference. So the first thing that you're going to do in this case to show that, you really have to produce the diagram that is summarizing the property itself. So here what I'll do, the first thing is to draw the diagram representing the information about the property. So our diagram in this case will always demand us to draw a circle which will look something like this. Look at this one. Right. So the property talks about the angle subtended at the center related to angle subtended at the circumference. So what I'll do here, I'll show in this my sketch a circle, right? What is referred by this? So here we talk of angle subtended at the center. We are referring to the angle that is produced by an arc at the center. So here I'll have my diagram which has got an arc A, B. I'll use the minor arc, not the major arc, to subtend angle at the center and the circumference. So let me have this one as my center O, and then another point on the circumference should be here. Let this one be T. Right, so let us have arc AB subtending angle at the center, which it be something like this. A line from A to O, like that. Line from B to O comes like that. Right? So here it tells us about the first part here of this statement of the angle subtended at the center. We are referring to this situation here. Arc AB subtending angle at the center. This one. Related to angle subtended at the circumference. So we're referring to the same arc subtending angle at the circumference. Here we have chosen point T. So this will look something like this. A line from from arc AB, that's it, from point A, and a line from B. Both lines are meeting at T. So here we have got this angle here, which is angle ATB related to angle AOB. So we'd like to show that, say, angle this one is twice angle that one. Right. So when you are proving in geometry, firstly, please can you draw the diagram like just what I've done here? Right. Now, having drawn the diagram, what is the next thing that you could do? You know, when you're proving something, you have to be logical. Right. It's about reasoning. Things have to make sense. I'm coming from point A, I'm going to point something. That must be logical. So begin by drawing the diagram like this one. Then now we go into the next step. And the next step is at least to state what you have. So like here, a diagram has been produced. The next thing that you do, you are going to explain what you have there in the diagram. So here you're going to write the statement about what you have. So you'd say now, given. What is that you have? You're going to use to show the statement here about the angle subtended at the center is twice angle at the circumference. So here you say, you have my diagram here. From the diagram, I need to explain this one out by saying, given the figure as above, where whatever that is important there has to be mentioned. You talk of O is what? Is the center. You can even add more information here on this stage. You can even talk of, say, AB is an arc that is subtending an angle at the center and the circumference, but don't write a lot of statements on that step. Just see, be brief. So here you have a diagram summarizing the theorem. And then now you write about the diagram to say, I've got a figure as above. You are referring to this figure where O is the center. Right. Having done that, stated that one. Let's say you have stated the diagram, you have described the diagram as such. The next thing you do is the objective. You need to tell us exactly what is it that we want to do. Right. Now, based on the diagram that I have here, what I need to do is to do this. Remember, what I want to do is just a matter of showing that is it really true that angle at the center is twice angle of the circumference. So when you have done the diagram, try to use the diagram to explain that. So here, specifically, what I want to do is just like to show that angle AOB is equal to 2 times angle ATB. Right. So the diagram that means simply this. It means this. AOB is equal to 2 times ATB. So you could see what is stated here are all what has been stipulated in the diagram above there. Right. So I have my diagram here. Then after, I have to state that everything about the diagram in the first statement say given. This is what I have. I explain about this. After, I have to state what I need to do from the diagram. So I have to there stating that, say, I would want to prove that angle AOB is equal to twice angle ATB, like that. Now, how do we show that one out? Right. For us to show AOB is twice ATB, we need first of all to look at the diagram as such to say, is the information enough for us to show the statement? If you find that the information in the diagram is not enough, you may be able to decide adding another information in that diagram that you feel is relevant and then can help you to prove your theorem. Right. So if I can look at my diagram here, yes, it has got information, but the information is not enough for I to show that this one is twice that. So what am I going to do? It means when I'll be writing out my processes, I need at least to include this step here, which is known as construction. A step known as construction. So under construction, you are going to write what you feel you can add on the diagram, and you feel that one is necessary. So like here, what I need to do with the diagram, I need to add information about radius. Right. So what I'll do here, the information of the radius is as simple as like joining the T to O. Yes, already have the radii here. A, O is a radius, B, O is a radius. But the two radii are not enough. So I need to add another radius there, so that at the end, I should have 3 radii. Right, so you have seen, I think here I need another radius to be added. So that's why you could see me here talking about this one, joining T to O, with an aim of having a third radii, added information. So what I'll come here, with my ruler, I'll connect T to O like this, like that one. That's what I want. So this is just like additional information. So it's described as part and parcel of what? Construction. Remember, it's not part of the diagram. It's just been added. Right. Next, I would say, oh, I think it's not enough if I can just leave things like that. But if maybe I can extend this to O further to any other point, let it maybe point F. That, I think it'd be better if I can have that. So this added information of T O extended to point F, that one is really enough information that can help us to process out the discussion here and come up with a conclusion that will give us, that will be able to demonstrate that, say, angle A or B is twice angle A, T, B. But now if you find that the diagram has just enough information, you don't have to bother. You don't have to bother adding any other information there. So which will mean at this part here, at this stage, you still more write construction and you can just write a dash, or you can just skip this stage here. Right. So now it's just like now, we have already this information. So what? We have already this information. So what? That is to say, how is the information added in the diagram that the already given going to help us and at the end be able to conclude that angle A or B is equal to 2 times angle ATB. Right. So what we're going to do here is just simple. Let's go to the diagram itself. Let's go to the diagram itself and see what we have here, how it's going to help us to show that angle A or B is equal to 2 times angle ATB. Right. Now, if you can look here, you'll be able to see that in the diagram, if I may use some kind of notations here about the angles, you'll be able going to bear with me that, say, in triangle TOA, and that's say in triangle TOB. Right. You are going to observe the following. I may give a notation to this angle as being x1, and then I'll also give this one as x2. Right. Look at this. Look at triangle, let's say A, T, O. You bear with me that this triangle A, T, O somehow is a certain type of triangle which is known as a isosceles triangle. Look at the sides, OT and OA. These two sides here are radii. Radii are always equal. So now they are part and parcel of the sides of the triangle. So expect that triangle, that's the A ATO is isosceles. So here we expect the angles, the base angles, which being this one and this one being equal. So that's why here my notation being this one is x1 and this one x2. It comes from that. Say base angles of isosceles triangle, which is ATO, are equal. Right. In the same way, if we come to triangle that is BOT, this one here, BOT, you find that this triangle again has got two opposite sides equal. Yes, you are not given, but you can still be able to tell that, say, line OB is equal to line OT. They are also radii. We understand that radii will always be equal. They are all lines which are coming from the same point, the center, and they're heading toward the same, to the circumference of the circle. So those ones must be equal. So here we take that this side here is also equal to that, by the same is also equal to that one. So we also expect that this angle here being equal to that other angle. Right. So if this one maybe can be given as y1, this one be y2. We're using the same y's here. It means this one is the same like that. So the two angles are equal because they are just base angles of isosceles what? Triangle, in this triangle BOT. The same angle, this one, x1 is equal to x2 because they are base angles of isosceles triangle, which is triangle AOT, from what we have just explained. Opposite sides of those two triangles are equal. Therefore, they really deserve to be, let's say, isosceles triangle. Now, having noted this, as again from what I've already explained, I've already talked of this to say y1 is y2, base angles of isosceles triangle, and the same x1 is x2, base angles of isosceles triangle. So on the proof stage, you need at least now to use the diagram what you have here, at least try to explain with facts and also with reasoning, and also with reasons of whatever you're going to mention here. Right. So now, look at this. If we say this is equal to this, that angle again is equal to that angle. So what? You find that again, if you have just mentioned that this is equal to this one, that one is equal to that one, you find that this information is also taking us to something else. It's going to now have an effect on the what? The angle which we are interested in with, angle AOB, which is angle at the center. Right. So let's see something about the angle at the center. What happens here in relation to the notation of the x and y. Right. So if you can look here closely, you find that if I can depict this triangle here, ATO, with an extension line TO to F, you're going to bear with me that we're going to have a triangle which have got the exterior angle, which looks something like this. Look at this. We go like this. This is your T, this is your A, this is your O, and this is your F. Right. So remember what we discussed in form 2. That say if I've got the two interior opposite angles, and these two interior opposite angles, if they're added, the sum of which is equal to the what? Exterior angle here. Right. So this property is portrayed in this what diagram here. You'll see that angle x1 and x2, if they're added, they'll give you this one here. So which means x1 and x2, if they're added, they'll give us what? 2x. Reason, exterior angles of what? Of the triangle. The same here, you'd also see that say angle y2 and y1 in this other triangle, when they're added, they also give us the value of this angle here. The same thing, you can talk of triangle TBO, extended line TO to F. You'll be able to see that when we add this y1 and y2, they'll give us this one here. That's still exterior angle of the triangle. So when you add this one and that one, it gives us this one as 2y, like that. Right. So in this case, you will be able to see that from what we have just discussed here, if I come to the chart to analyze that, you really see that say the angle which we are targeting, this is angle ATB, is just x plus y, and the angle AOB is equal to 2x plus 2y, if we can consider the whole of this angle here. Because our target are AOB and ATB. We just want to look at their relationship. So if we are taking of this angle as ATB is x plus y, and this one is equal to 2x plus y, then we can do some kind of analyzation there mathematically into something like this. Look at this. X plus y, x plus x is angle AOF. This one here is 2x from what I've said. Y plus y is angle BOF. That's the BOF. You can look at that. It's giving us 2y. So here we have angle AOB, as I've already explained. AOB is equal to 2x plus y. But now, if we can have that summation of 2x plus y into something like this and think of factoring out a 2, you'd be able to see that you're just going to divide the 2 here. You get what? That is x. 2 there, you get what? Y. So what we have here, just like AOB is giving us 2, open bracket, x plus y. AOB is equal to, I repeat, that's a 2, open brackets, x plus y. So it's just like, if you look at x plus y, 2x plus y, you'd really again to compare to say x plus y is just angle what? Angle ATB. So you'll be able to see that, say, instead of now lighting the x plus y, we can substitute that one by light what? By lighting what? That is the ATB here. Right. So that concludes the discussion here. There's nothing else we can do here. Because if I light angle A or B, I light here like this, 2, that x plus y, then definitely, instead of lighting x plus y, yeah, you know, it is the angle what? ATB. So it means you have just lighted 2, angle A what? TB as such. So this one has at least helped us to understand that really angle at the center is really twice angle at the what? At the circumference. Right, so I've concluded that way to say, when I've written here and look at this, but this one is equal to that one, then we finally conclude that say angle AOB is equal to angle ATB as such. So the main principles in the story are just simple. Make sure you draw the diagram and then do the construction from T to O and then extend that one to F. The aim is just to have 2 isosceles triangles and then have again 2 triangles which have got what? Exterior angles. So you just use the mathematics in that, that is that, this is that, then you sum up, this plus this gives you this plus that gives you that, you add this one is 2x plus 2y, you factor this, the result will be this one. So it means that the 2x plus y is as good as lighting 2ATB. Right. Thank you very much for that. I hope you have understood this and now you're going to accept the knowledge fully that say every time we have a circle or a question about the about a circle and talks of the situation about an angle subtended by an arc at the center and the same arc subtending angle the circumference, I think you are able to accept that knowledge that the relation will remain the same. At the center is twice angle the circumference as such. Thank you very much for listening. Right. In the next video, we are going to discuss the other 2 properties, and there we're going to have some examples and exercises. But the exercise for this one was already done in the previous video. Here we are just like analyzing up the story. Thank you very much.